Ever wonder what's really in a can of paint? Besides the color. Well, there's a whole world of fascinating chemistry hidden in there. Today, we're going to pull back the curtain on one of the most important but totally overlooked ingredients. Let's get into the amazing story of barium sulfate. So, here's what we're going to cover. First, we'll meet this hidden workhorse of the paint world and see how it just blows its rivals out of the water. Then we'll dive deep into the science behind its superpowers, see how that translates to real-world performance and cost, and find out how chemists fixed its biggest flaws. We'll wrap things up by looking at its most powerful partnership and, of course, putting on the final coat. All right, so in any can of paint, you've got these things called fillers. They're the unsung heroes that add bulk and seriously boost performance. And while there are a lot of different materials out there vying for the job, one of them really stands out. Let's see why barium sulfate is a true champion in this space. Just take a look at this one key stat, oil absorption. Barium sulfate is incredibly efficient, soaking up only about a third of the oil compared to a really common filler like aluminum hydroxide. Now, why is that such a big deal? Well, think about it. Less oil absorption means you need way less of the expensive binder, the resin, to get the job done. And that simple fact, well, it kicks off a whole chain reaction of amazing advantages. Okay, so what is it about barium sulfate that gives it this incredible edge? What's the secret sauce? Let's unpack its fundamental chemical and physical, well, let's call them superpowers. This table pretty much lays it all out. It's got a super high specific gravity. That's just a fancy way of saying it's really dense, it's heavy. Its melting point is sky high, so it can definitely take the heat. Its refractive index, how it bends light, gives paint that bright, glossy look. And it's pretty hard, which makes the final paint job way more durable. Let's zero in on that number, 4.45. This is the highest specific gravity you'll find in any common filler. And that density, that heft, it's a feature, not a bug. It makes barium sulfate a fantastic weighting agent, helping to create a really dense, stable layer of paint that's perfect for things like anti-corrosion coatings. Now for this number, 1580 degrees Celsius. That is insanely hot. This extreme resistance to heat makes barium sulfate the go-to filler for powder coatings. The kind that get baked onto things at super high temperatures. It just sits there, totally stable, which guarantees a beautiful, high-quality finish. So all this cool science is one thing, right? But how does it actually benefit the people making the paint and ultimately you? Well, it all boils down to two things: performance and cost. Remember we talked about that super low oil absorption? This is where it all pays off. Because you're using less of that expensive resin, you can pack more of the good stuff, the solids, into the paint. That means a thicker, more protective film, lower VOCs, which is great for the environment, and the big one, huge cost savings. It's really the secret weapon for making a great, affordable paint. At this point, you're probably thinking, wow, this stick is perfect, right? A flawless hero for our story. Well, not quite. Like any great character, barium sulfate has a critical weakness, a sort of Achilles heel that we need to talk about. And here's the catch. Its biggest strength, that high density, is also its biggest problem. It's so heavy that it has a nasty habit of sinking to the bottom of the can in liquid paint. And on top of that, its surface is naturally hydrophilic, which means it loves water. That makes it really tough to mix evenly into modern oil-based or organic paint systems. But chemists are a clever bunch. They weren't about to give up on our hero. Nope. Instead, they figured out a way to solve these problems by essentially giving the particle a complete personality makeover. So that's the puzzle, right? How do you get a particle that absolutely loves water to play nice and feel right at home in an oil-based world it naturally wants to avoid? And the answer is just so elegant. It's called surface modification. The best way to think about it is like giving each tiny little particle of barium sulfate its own custom-fit, water-repelling raincoat. This tiny little jacket completely changes its surface from being water-loving to oil-loving. And I mean, look at the difference here. It's night and day. Before you treat it, the particles just clump together and refuse to mix in properly. But after, with their new hydrophobic coating, they spread out perfectly and evenly. You get a completely stable, super high-performance paint. It's a total transformation. And what's really cool is that you can pick the right raincoat for the job. Stearic acid is a fantastic, cost-effective all-rounder. For maximum durability, you can use something called a silane coupling agent, which creates this incredibly strong chemical bond between the particle and the resin. And then there are phosphate esters, which are specifically designed to handle the intense heat of powder coatings.
Okay, so our hero has overcome its fatal flaw. Now it's ready for its biggest role yet, teaming up with the most famous, most important ingredient in paint to create something truly special. Let's talk about the superstar of white paint, titanium dioxide, or TiO2. This stuff is the undisputed king of whiteness and opacity, what painters call hiding power. It is literally what makes white paint white. The only problem, it's also by far the most expensive thing in the can. And this is where barium sulfate becomes a total game changer. Its particles work like perfect little spacers. They get right in between those expensive TiO2 particles and keep them from clumping altogether. By doing that, they make every single particle of TiO2 way more efficient at scattering light. And the result is just incredible. You can actually boost the paint's total hiding power by up to 10%.
This leads to a really brilliant trick that paint makers use. They can replace a chunk of that pricey titanium dioxide with a much cheaper barium sulfate. A really common mix is to swap out about 20%.
So what does that actually mean? Let's talk money. By making that 20% swap, you can cut your raw material cost by around 15%. And you do it all while keeping or sometimes even improving the paint's performance. That is a massive win-win.
All right, let's put the final coat on this story and go over the key things to remember about our unsung hero's journey. So, to sum it all up, barium sulfate is so much more than just a filler. It's a multifunctional tool that adds weight, gloss, and hardness. It's incredibly flexible, ready for any kind of paint system. It's a smart partner that makes other ingredients better and saves a ton of money. And the absolute key to unlocking all that potential, that clever little raincoat, surface modification. It's really something to think about, isn't it? The next time you walk by a freshly painted wall, you'll know one of the secrets behind that smooth, durable finish is a humble mineral wearing a high-tech raincoat. And it gets you wondering, what other supposedly simple ingredients are out there, hiding some transformative science right under our noses?